This is the start of our mod guides for mod 24. We are going to take a look at really repeating what we've already done with proportions, but now for means. And in this module, we're going to look at estimating a population mean with a confidence interval. So I just wanted to talk about how this works in theory before we look at actually constructing one. So just like with proportions, we're going to need to start with a normal sampling distribution. So what you saw about this normal sampling distribution of sample means in our mod 23 activity is that it will be normal as long as our sample size is big enough. So again, the sampling distribution of sample means is our distribution where all of the values along the horizontal axis are sample means. The center of this distribution, the mean of all the x bar values, is equal to the population mean mu. You did see that in your activity. What you also saw in your activity is that the standard deviation of this distribution, which is now called sigma x bar, was dependent upon sample size. As the sample gets bigger, this standard deviation, now called standard error, gets smaller and smaller. So the formula that produces that is the population standard deviation sigma divided by the square root of the sample size. And again, having that sample size in the denominator means as it gets larger and larger, the overall fraction, the standard error, is getting smaller and smaller. To make this sampling distribution normal, the sample size that you need is one that is greater than or equal to 30, or you need that the original population values, so that would be the plain X values, the data you're collecting from individuals. This distribution is about X bar values. It's about sample means. But we'll have a normal distribution if the original population values are normally distributed. Or, of course, if our sample size is greater than or equal to 30. Now, this is the normal sampling distribution that has to start. But when we create a confidence interval, we're always making that estimate based off of our sample. So we're putting our particular sample mean right at the center. And so we've moved our curve, maybe left, maybe right, maybe a little, maybe a lot. We don't know, because generally we don't know what this population mean is that we're trying to estimate. So we don't know how we moved it, but now we've just set it down so it's centered over our sample value, and we find the endpoints to enclose the desired percent of our curve. We're going to start off with a problem that uses a 95% level of confidence, encloses 95% of the area. So we'll do that from the empirical rule, and then we'll move into using StatCrunch for other levels of confidence. So just to kind of remind us about how what we're doing for means is exactly what we did for proportions. Our standard error in the SDSP, we abbreviated sigma p hat, and this was our formula, square root PQ over N. Now, in the sampling distribution of sample means, the standard error is abbreviated sigma x bar, and this is our formula, sigma over the square root of n. Margin of error is always the distance from the center to the endpoint on either side. In a 95% interval, and only in a 95% interval, does that margin of error equals 2 times the standard error. So that is true for both means and standard deviations, but again, only when we're enclosing 95% of the error. And so down here, you have confirmation of this relationship between margin of error and standard error. So to get the endpoints of your interval for a proportion, you start at your center value, p hat, add and subtract either one margin of error or 2 times the standard error. For our confidence intervals, we start at our sample value, x bar, and then again, either add or subtract one margin of error or 2 standard errors. Down at the bottom was the criteria in order to be able to do this. Expected successes and expected failures of at least 10. That was our criteria, that NP and NQ are greater than or equal to 10. And here, our variable is normally distributed, or our sample size is more than 30 is the new criteria that we're applying to means.